TRACE32 as GDB Back-End. Rapid development tools. TRACE32 as GDB Back-End. TRACE32 GDB Back-End Introduction. TRACE32 PowerView implements a GDB server or stop functionality. This provides an interface to any application using the GDB Remote Serial Protocol (RSP) to control the TRACE32 PowerView via TCP. For the end users, this document presents the supported target architectures, the operation theory of the GDB backend and the solution restrictions, how to configure TRACE32 as the GDB backend, TRACE32 integration to some example front end via the GDB interface. For the users interested in the integration of the TRACE32 with their custom GDB front end, this document presents the limitations of RSP and the protocol extensions defined to overcome them. For information about using TRACE32 to debug, for example, virtual target over GDB stub or to debug an application over GDB server, please refer to TRACE32 as GDB frontend _gdb.pdf. Related documents. For information about how to install, for information about the TRACE32 configuration, please refer to Training Basic SMP Debugging. And then, the supported architecture, TRACE32 GDB stub is supported the following architecture. Blah 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 blah. And the operation theory and restrictions. TRACE32 PowerView receives a command from the remote GDB frontend, execute them and send the response back to the frontend. The communication to TRACE32 PowerView is implemented as a socket interface. This means that GDB frontend and TRACE32 PowerView can reside on the different hosts using network connections for the communication. TRACE32 backend routes the GDB request to the TRACE32 hardware. The answer to the request goes exactly the opposite way, returning information to the GDB frontend. The GDB requests are operated just beside a normal TRACE32 operation. You can use both the TRACE32 PowerView and the GDB frontend interchangeably, although it is not recommended. The GDB frontend won't be informed about changes that are done in the TRACE32 PowerView. Due to some limitation of the remote serial protocol, extended TRACE32 functionality like trace views, MMU views, and OS-aware debugging is not supported. TRACE32 setup. To configure TRACE32 PowerView as GDB backup, GDB backend, use the command setup API GDB enable. You can specify a port number using the /port option. If no port number is specified, default port number is 30,000 will be used. 30000. Example 1. Setup API GDB enable. Enable GDB server in TRACE32 using default port 30,000. Example 2. Setup API GDB enable. Port 12345. Enable GDB server in TRACE32 using port 12345. GDB frontend setup. TRACE32 view could be controlled by any frontend that supports GDB RSP, Remote Serial Protocol. This section presents some examples of third-party tools that could be configured to control TRACE32 PowerView via its GDB stub. The GNU Project Debugger GBD. And the following example, GBD multi-archi is used. The other alternative is to use the appropriate GDB for the selected architecture. GDB multi-archi Junior GDB Ubuntu 7.11.1, 0 Ubuntu 1, 265.5, 7.11.1. Copyright is 2016, the Free Software Foundation Incorporation. Okay, make sure that you set the correct architecture, and this example, the architecture ARM is used to control the TRACE32 power view for ARM. The GDB set architecture ARM, the target architecture is assumed to be ARM. 2. Connect to TRACE32 power view using TCP. Here, the local host address 127.0.0.1 is used. If the TRACE32 power view is started on the different machine than one running GDB, the remote machine IP address needs to be used. At this level, there are two different ways to start the GDB session. It depends on the status of the communication between the TRACE32 debugger and the target. If the debug communication between the TRACE32 and the target is already established, TRACE32 power view should show the example system ready in the status bar. Then the target remote needs to be used. Like this. So after the debug communication between the TRACE32 and the target is not established, TRACE32 power view should show the example system down in the status bar. Then the command target extended remote needs to be used. And the following example, the monitor commands are used to initiate the communication between the TRACE32 and the target. For more details, please use the monitor commands. Like this. Now, you can continue debugging the urge using the GBD command line. For example, set symbol file is relative to the application loaded into a target memory. GDB symbol file, save the ELF, reading symbols from the save the ELF done. Set a breakpoint, save, breakpoint 1 at 15E6 file, source save.c line 798. 798. Continue program execution. GDB continuing. Breakpoint 1, save app. And at 798 is counted 0. Monitor command. TRACE32 GDB staff support the following monitor command. Help. The command monitor help return the string the TRACE32. B ::cmd. Execute the TRACE32 practice command. Example, monitor B var set mcount1. The eval func get the return value of a practice function. Example, monitor eval register PC. Practice state. The command monitor practice state return the long state of the practice. 0 non-learning, 1 learning, 2 dialog window open. The system mode HLL AMS. Execute an assembly or a high-level single step, and when getting the GDB RSP step backend. Default is ASM. Sync on-off. Enable disable software component in the component that allows the TRACE32 instance to connect to other instances by executing the TRACE32 command sync.on or sync.off. Defaultly set. Core or system. Core. Execute the command the system.option and reset off. System. Execute the command the system option and reset on. Reset debug. Execute a system boot up. Example. GDB monitor health TRACE32. Monitor eval var volume mcount 00000792. Monitor b::dataset 100, actually 100, long 0, and monitor eval var var.value count 0000000, monitor b 00 quick remote connection close equals. It's possible to control trajectory power view via each GDB stub from equals. However, it's recommended to use the target communication framework TCP instead, since it offers more features. For more details, please refer to the TRACE32 at TCP agent f_tcp_setup.pdf. The following screenshots are generated using the Eclipse IDE for C or C++ developers. Oxygen .2 release 4.7.2. Unit configuration Eclipse as follows. Add a debug configuration for remote application to your Eclipse workspace. In the debug configuration window, you need to select the configuration GDB DSF manual remote launcher, like here. In the second, in the debugger tab, select your GDB debugger according to your target architecture. 3. Set the connection configuration according to your TRACE32 PowerView setup. Set host name or IP address of the machine running the TRACE32 PowerView instance. Set the port number according to the GDB port configuration of the PowerView instance. 4. Before you try to start debugging from the Eclipse, you need to make sure that the debug communication between TRACE32 and the target is already established. TRACE32 PowerView should show, for example, system ready in the status bar. Next is the Microsoft Visual Studio. Starting from the Microsoft Visual Studio 2015, it is possible to install the GDB debugger extension for Visual C++. This introduces a new project type that provides additional project properties and allows to connect the Visual Studio debugger to a GDB stub. The following screenshots are based on the Microsoft Visual Studio Professional 2015, so you need to configure Visual Studio as follows. Create a new project by selecting the template, Make Project GDB. 2. Set up the debugging configuration on the project property scope properties page. Choose the item local GDB. Set up the correct GDB debugger executable according to your target architecture. In this example, a configuration for the ARM architecture is used. Configure the local debugger server address with the IP address or host name of the machine and running the TRACE32 PowerView instance, the GDB port number of the TRACE32 PowerView instance. 3. Make sure that the debug communication between TRACE32 and the target is already established. The TRACE32 PowerView should show, for example, system ready in the status bar. The Visual Studio Code. You need to configure Visual Studio Code as follows to establish a connection with the TRACE32 PowerView. Select the menu, Run, Add Configuration, then the empty configuration, brace, open brace, and close braces. Set up the following parameters, blah blah blah, name, type, request, target, GDB path, CWD, current working value formatting, and auto run. Example 3. Start TRACE32 PowerView with the startup script in order to establish connection with the target. 4. To start debugging, select the menu, Run Start Debugging or press F5. Note: VS Code may display a red message. Exception has occurred at the program counter position in the message. the not implemented stop region, assuming the exception, undefined, and the debug console, this message can be ignored. You can additionally replace the TRACE32 built-in editor code with a call to the Visual Studio Code editor using command setup.edit text. Edit setup.edit text on quad path to the VS Code exe -G quad double quad asterisk colon pound double quad. If you use the right mouse click on the TRACE32 list windows and select Edit Source, the file will be displayed in the Visual Studio Code and the selected line number. Remote Serial Protocol. The TRACE32 GDB stub supports almost all packets defined by the Remote Serial Protocol, except some packets that are generally not needed to control the TRACE32 power view via the GDB stub. If you need an exhaustive list of the unsupported packets, please send a request to support@lautbach.com. Protocol extension. The Remote Serial Protocol does not provide a way to distinguish between the different memory types. When the RSP protocol is used to communicate with the GDB stub other than a GNU GDB server, the memory address is not always sufficient to identify a unique physical memory location. Depending on the access mode, the same memory address could refer to a different physical memory locations. For example, secure non-secure memory for the ARM architecture. To overcome these limitations, Lauterbach has defined a protocol extension, a packet-to-reader length addressable memory of the type defined by the access class starting at address qtrace32.memory access class and address and length. A packet write the length addressable memory of a type defined by access class starting at address. This data is given by the values. Each byte is transmitted as a 2-digit hexadecimal number. qtrace32 memory and access class address length of the values. If the TRACE32 software version implemented this protocol extension, it should include the string qtrace32 memory plus qtrace32 memory plus in the reply to the q-supported packets. These available access classes are dependent on the processor architecture in use. Therefore, refer to the access class memory class section of your processor architecture manual for more details. The symmetrical multiprocessing support. In order to support symmetrical multiprocessing, SMP debugging over the GDB interface, TRACE32 considered each core from an SMP system as a thread. Thus, or the RSP packets relative to the multi-thread handling are used for multi-core handling. Today I read this material, the TRACE32 GDB Back-End from Lauterbach Development Tools. Thank you for your time. See you next time.